Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding the number system. At the end of this video, the student will gain knowledge regarding how the data can be represented in the computer system, what are the various formats of numeric representation, and what are the various number systems and conversion from one number system to another number system with examples. So the topic learning outcome will match the course outcome of gain knowledge about number system and conversions with examples. And the basic topics that are discussed in this video are introduction, what is number system, binary number system, octal number system, hexadecimal number system, and examples. So generally in a programming languages, while various data types are available to represent what type of data that is used in the processing, like int, float, string, like this. But in case of computer organization, the data can be stored in the registers of a computer. And these types can be the number, letter, or special symbols. Generally, the numbers can be represented with number system. Letters and special symbols are represented with the special code, that is the ASCII code, American Standard Code for Information Interchange. So, in the number system, majorly the radix is the major element. What is radix or base means? Number of elements are what are the number of digits, symbols used in that particular number system that can be indicated with the radix or base. Generally, the small letter r is used to denote the radix of the particular number system. So here, for example, if you take the decimal number system, generally the decimal number system we can use 0, 1, 2, 3 until 9. So totally 10 number of symbols we can use to represent the numbers. So the base or radix value is 10. In a binary number system, the data can be represented either with 0 or 1. Totally 2 symbols are used to represent. So here the base or radix is 2. In case of octal number system, 0 to 7, totally 8 symbols are used. So the base can be 8. In case of hexadecimal system, 0 to 9 we can use, and to represent the other digits we can use the capital A to F letters. So totally 16 symbols are used. So the base value of hexadecimal system is 16. So here this is the decimal. This chart will display the values with the particular number system. So these are the decimal values to represent. In case of binary with base 2, how these can be represented? The 0 is represented with all zeros, and depending upon the place value of this binary number system, these values can be represented. And in the hexadecimal also, how these can be notated. So until 0 to 9, the value 9 digits can be represented. After that, to represent 10, the hexadecimal number system uses capital A. So 11, capital B. Like that, A to F letters can be used to represent the corresponding numbers from 10 to 15. So in this way, the number systems can be used with the particular digits in the corresponding system. Now, how a binary number can be converted into the decimal. So here, if you take this here, 3, how it is represented in 0011 form. So depending upon the place value in the decimal number system, these value can be converted into the binary form. So here the digit values multiplied by the positional value of the binary number system. So here if you want to take the number 1010, 0 multiplied by 2 power 0 position, next 1 into 2 power 1 position, 0 into 2 power 2 position, 1 into 2 power 3 position. And all these values can be summated to get the decimal equivalent. Now consider one example 1011. How it has to be converted into the decimal form. So here first we have to write the digits 1001, and with these digits has to be multiplied with corresponding positional value. So 1 into 2 power 0 plus 0 into 2 power 1 plus 0 into 2 power 2 plus 1 into 2 power 3. And what is the values you can get can be summated to represent the decimal equivalent of binary number 1001. So 2 cube is 8 into 1 8 plus 0 multiplied by anything 0, 2 power 0 1 into 1. So we can get the 9 in the decimal form. So 1001 is the 9 in decimal form. So you can generate a simple binary number to the decimal form by multiplying the corresponding positional value of that number system and adding the terms so that we can get the converted decimal number. So how to convert this binary number into the decimal form? So this is 111. So here 1 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3. So it is 8 plus 4 plus 2 plus 1. So it is 15. So the decimal equivalent of 4 ones in binary is 15 in the decimal form. How this can be accomplished with the floating point numbers? So after decimal point, the digit can be 2 power minus 1 and the next one 2 power minus 2. So which is equivalent to 1 by 2, 1 by 4. So here we have to multiply the digit with the positional value. So you can know that how the integer part can be done means 1 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3. And the fractional part is 0 into 2 power minus 1 plus 1 into 2 power minus 2. So we have to add these ones. So 8 plus 4 plus 2 plus 1, this is the integer part, and this is the 0 multiplied by anything 0. So this is the 1 by 2, that is 0.5. This is the 0.25. So here plus 0.25. So its value can be the 15.25 in case of the decimal number. So in this, each digit can be multiplied with the corresponding positional value of the number system, and the terms can be summated to get the equivalent in the decimal number system. Next, consider one more example so that the particular positional value has to be converted here. So here 1 into 2 power 0 plus 0 into 2 power 1 plus 0 into 2 power 2 plus 1 into 2 power 3. Next 0 into 2 power minus 1 plus 1 into 2 power minus 2 plus 1 into 2 power minus 3. So here 2 cube into 1 is 8, this is 0 and this is 0 and this is 2. And here it is 0 plus 0.25 plus 0.125. Okay. So here the integer part can be the 10 and here we have to add 0.125 with the 0.25 so that we can get 0.150. So this is the decimal equivalent of the binary number. So in this way the integer part and the fractional part can be converted. How the octal numbers are converted into the decimal. So here the base value for the octal number system is 8 and this base value and the positional value has to be used in the conversion of octal number to the decimal number system. So here the first position value 8 power 0, 8 power 1, 8 power 2. In order to convert this 1 into 8 power 2, 4 into 8 power 1, 3 into 8 power 0. And the terms has to be added in order to get the decimal equivalent of octal number 143. So here octal number can have base value 8 so that 8 positional can be used here in case of octal number to decimal number conversion. So here 146 can be converted into the decimal number system. So the positional values can be taken into consideration. So 8 power 0, 8 power 1, 8 power 2 can be used here. And 8 power 0, 1, 6 plus 32 plus 64. And these terms can be added in order to get the decimal equivalent of the 146 equivalent. So we have to add these numbers. And 0 to 10. So this is the decimal equivalent of the binary is octal number 146. Similar way, the fractional positions can also be used. So here 146, how to convert, you know that 6 into 8 power 0 plus 4 into 8 power 1 plus 1 into 8 square. 0.1 into 8 power minus 1 plus 1 into 8 power minus 2. So this is the 6. The integer part can be 32 plus 64. And fractional part 1 by 8 value is 0.125. 125 plus this is 0.015. We have to add all these numbers. So here we have to add. So this is the equivalent can be the 102.14 is the 10 conversion. So in this way the fractional part can be converted into the decimal one. How the hexadecimal number can be converted? Here the base of hexadecimal number is 16. So that this base value can be used and the positional value can be used to multiply. So here E is indicated with the digit of 14. So 14 into 16 power 0, 7 into 16 power 1, 3 into 16 square, 10 into 16 cube. So the terms can be added in order to get the decimal equivalent of hexadecimal number. Now consider one example, that 1A2. So here 2 into 16 power 0 plus A means 10 into 16 plus 1 into 16 square. So this is 256 plus 160 plus 16 power 0, 1 into 2, 2. So we have to add all these numbers, which is 418 is the equivalent of decimal equivalent of the 182. Now how to convert from decimal to other number systems. So here if you take decimal to binary conversion, the number can be divided with a base value of binary number system 2 and the remainders can be written in bottom to top fashion in order to give the concerned binary number equivalent of specified decimal number. In case of octal number, the base value is 8 so that the number can be divided with 8 and the remainders can be written in bottom up fashion to get the octal equivalent of particular decimal number. In case of hexadecimal, the number can be divided with a base value of 16 and the remainders can be written in bottom to top fashion to get the hexadecimal equivalent of decimal number. We will look into with examples how these conversions can be take place. How to convert 57 decimal value with the binary value. So 57, we have to divide the base value of binary number is 2 with 2. 1 is the remainder. Next 2, 0 is the remainder. Next 2, 7 is, so remainder 0. 3, 1 is the remainder. 2, 1 is the remainder. 2, 0, 1. Now we have to write these remainders in the bottom of fashion. So 0, 111, 0, 0, 1 is the binary equivalent of 57. So in this way, the decimal number can be converted into the binary number. Now how to convert this decimal number into the octal number. So take the 576 and the octal number base value is 8. Okay. So with these the base value is 8. We have to divide this 557 with the octal number 8 value. So why we are taking the radix value of the octal number is 8. That's why the decimal number has to be divided into 8. Okay. Zero. So the decimal equivalent, the remainders has to be written in bottom up fashion. So this is the octal equivalent. Similar way, how to convert the decimal number into the hexadecimal number. So you take the number and the hexadecimal base radix value can be the 16. So we have to use this 16. So this is the equivalent value in the hexadecimal number system. In this way, while converting from decimal number to the corresponding number system, the decimal number can be divided with the corresponding radix value of the number system. And whatever remainders get, that can be written in bottom up fashion in order to get the equivalent converted number of the corresponding number system. Now, how to convert from octal number to the binary number? So, octal number can be used to represent each digit in a 3-digit binary value. So, the equivalent of 4 and equivalent of 5 can be written so that we can get the equivalent binary number. So, to do this, generally in the binary system, the values can be the positional values 2 power 0, 2 power 1, 2 power 2. So, to represent the 0, all these positions can be zeros. To represent 1, so this is the 1. So, and these can be the zeros. And to represent 2, this is the 1, all these can be zeros. To represent 3, these 2 are 1s, this position value can be 0. To represent 4, this is 1 and these values can be 0. To represent 5, these 2 can be 1 and this value can be 0. So like that, what is the equivalent of that particular binary equivalent of that particular number can be written in order to get the binary equivalent. So here the digits can be 4 and 5. To represent the binary equivalent of 4 is 100 and the binary equivalent of 5 is 101. So this is the binary equivalent of octal number 45. Now how to represent with a floating point these numbers? So to represent what is the 3 value, what is the 2 value, what is the 1 value, we have to write in the binary form. So here 3 can be represented with 0, 1, 1. This is the number 3. And 2 can be represented with 0, 1, 0. And 1 can be represented with 0, 1. This is the representation of binary equivalent of 1, 2, 3. Point, how 2 can be represented? 1, 0, 1. So, this is the equivalent of the binary value. Now, if you given the binary number, how to find out the octal number? So, here, whatever in the previous case, the equivalent of binary digits we written for conversion from octal number to binary number. In case of if at all it is given the binary number to octal number, you have to group the 3 digits as one group so that the equivalent corresponding value in the octal number can be represented. So here the binary number that is given in the problem is 0, 1. So we have to group the 3 digits of this binary number. If at all any shortfall of number of digits, we can add the leading zeros. So 001 equivalent is the 1 and 111 equivalent is 7. So in the octal number, it could be the 71. So here we have to group 3 bits as is and write the equivalent number of octal. So in case of floating point, how this conversion can be taken place? So here the number can be written so we have to group 3 bits each and write the equivalent octal number. 101 is the 5 value, 001 is the 1 value. 0.111 is the 7, 100 is the 4. So this is the equivalent octal number. In this way, the floating point can be converted into the corresponding octal number. Conversion from binary to the hexadecimal. In case of octal number, 3 bits are enough to represent the position of each binary number in the octal number. But in case of hexadecimal number, 4 bits can be grouped to represent the corresponding hexadecimal number. So if you take here the problem 00100011. So grouping of 4 bits and writing its equivalent hexadecimal value. So if you look into this chart, 0011 is the 3 value. So this is the 3 value. And 0010 is the 2 value. So this is the hexadecimal 23 value. So in this way, we have to convert. How to convert the hexadecimal number to binary number system. So if it all hexadecimal number is given, the 4-bit equivalent of that binary number can be written in order to take the conversion. For example, take 238 of 16. What is the equivalent of binary number? What is the 8 equivalent in the binary? It should be 10000. What is the 3 equivalent in the binary? It is 0011. What is 2 equivalent in the binary? It is 0010. So this is the binary equivalent of hexadecimal number. And in case of fractional part, how it can be converted. So here take 146.48. So what is the 6 equivalent? It is 0110. What is the 4 equivalent? It is 0100. What is 1 equivalent? It is 0001. This is the to represent integer part. To represent fractional part, the 4 equivalent can be 0100. 8 equivalent can be 1000. So this is the binary equivalent of hexadecimal number. So in this video, I will discuss what is number system, what is the base of various number system, how to convert numbers from one number system to another number system with examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.